Let's see this question. We want to integrate z times e to the x squared plus y squared over the cylinder given. So we have three directions. We have x direction, y direction, and z direction. So x squared plus y squared less than or equals 1 give us this disk. So in these two directions, so unit disk is 1, this is the -1. And x-axis and the y-axis. Right? So one way you could set up integration in terms of x, y, z. So z direction, let's put the z direction outside. Z direction goes from 1 to 4. And that may be dy, dx. Right. So we see y direction goes from, so this, let me use different color. Goes from this half semicircle to this half semicircle, right? So which means we could fix x direction if we want, or we can fix y direction. So we could do this. We do from -1 to 1 for 1 for x, right? This -1, this will be +1. Let's see, that's y direction. Fixed y direction goes from -1 to 1. Then the x direction will be going from negative square root of 1 minus y squared, the lower half semicircle, then positive square root of 1 minus y squared. And the integral, we have z times e to the x squared plus y squared. So this is difficult to integrate. So what do we want to do? We want to use cylindrical coordinates. Right? Cylindrical coordinates basically we want to use polar coordinates. Let's say a point here. One way, this point called xy. Another way you can look at this point as a point on the circle with a radius r, or in this case, radius just 1, right? Because it's a unit circle. So radius 1, and this angle theta. So clearly we see x value equals to 1 times cosine theta, and y value equals to 1 times sine theta. So we want to use that. So basically we want to write this integration in terms of dz, d theta, dr, right? Change of variables. Z direction doesn't change, goes from 1 to 4. But now instead of talking about xy value, we can talk about r and theta. We know from dx dy dz to dr d theta dz, the Jacobi is r. Right? That's calculated from x equals r cosine theta, y equals r times the sine theta. Then we can calculate Jacobi, which is partial x, partial r, partial x, partial theta, partial y, partial r, partial y, partial theta, right? So this is a 2 by 2 matrix. That's a transformation because the change of variables, basically transformation from x, y, z plane to r theta plane, r theta z plane. And the Jacobi is r, so dx dy dz equals to r dr d theta dz. Now the unit circle, so clearly the unit circle, the r goes from, so r is the first one, right? Theta goes from 0 to 2 pi. Right? Theta, the angle goes from 0 to 2 pi, and r goes from 0 to 1. And inside the integrand, z still z, and now e raised by x squared plus y squared equals r squared, right? We have x squared equal to r squared cosine squared, y equal to r squared sine squared, cosine squared plus sine squared is 1. So divided by r squared, that's our integral. Now the integral is free from theta, so we can just calculate a theta direction. So theta direction, we get 2 pi minus 0, which is a 2 pi. And we can integrate z direction, right? Z direction we get it from z squared divided by 2, by integration by power rule. Then we evaluate from 1 to 4. Then r direction, we have this e raised by r squared, then we have this r. Right? Then if we have e to the u, use u substitution, right? Use u substitution, let u be r squared. Then du will be 2r dr. So we want to multiply by 2, then offset by half. Then divided by 2. So then integrate in r direction. Integrate in r direction with e to the something, to the e to the something. You have e to the u, but in our case, it's e to the r squared. Then we will evaluate the r direction from 0 to 1. Now what do we get? So we get pi times z squared 4 squared, 4 squared 16, 16 divided by 2, 8, minus z squared 1 squared minus half. Right, that's the evaluation from z direction. Then r direction, we get e to the 1 squared, which is times e to the 1, minus e to the 0. E to the 0 is just 1. Simplify this, so we get a minus half, or that's 16 divided by 2, so we get 15 divided by 2, then have pi, then I have e minus 1. And that's it.